So today we are going to see some questions in stop and wait protocol, right? Great. Okay. So do you want me to quickly just recap the efficiency and throughput, the definitions, because we will be using them again and again here today. Okay. So what is the efficiency? Efficiency is just like, I mean, see, I'm talking about the stop and wait protocol. So here in these protocol, in stop and wait, or we will see other protocols, in those protocol, we have some time in our hand. So generally the time is, can you tell me what is the time that we have in our hand? This is, let me write TT plus 2TP in that way, right? TT plus 2TP. That is the time in our hand. Yes, which we also call RTT. Yes. Okay. I mean, generally that is the time, but if they give you, let's suppose if they give you transmission time for acknowledgement also, then you need to add the transmission time for acknowledgement. If they give you, let's suppose processing time for something, then you also need to add the processing time and so on, right? So basically, I mean, you might need to add some other times here, depending on what they give you in the question. But this is, I can say in general, like they ignore all other times. So that is why I'm just writing that time, right? So efficiency is, okay, before I define the efficiency, can you just tell me, if I want to send, let's suppose the bandwidth is BW. If I want to send some packets or, I mean, in this time, how many packets we can send? If I want to send some packets, then how many packets we can send? Can you tell me? You need to divide. See, in TT time, you can transmit one packet. In 2TT time, you can transmit two packets, right? In 5TT time, you can transmit 5 packets. So basically, you're just dividing by TT. I mean, if I just ask you the number of packets, you're dividing by TT. So if you divide by TT, it will come out to be 1 plus 2A, where A is TP upon TT. Okay. Okay. Coming to the next thing, which is that how many bytes you can send. So these are the packets. If the bandwidth is BW, then how many bytes you can send? Let's suppose the bandwidth is 100 bytes per second. And if I ask you in 1 second, how many bytes you can send? Maximum you can send 100 bytes, right? In 2 seconds, you can send 200 bytes. In half second, you can send 50 bytes, right? In half seconds, you can send 50 bytes, like that and so on, right? So that's what we have already discussed. So if I just ask you in half second, you can send 50 bytes. So basically, if you want to find out number of bytes in some time, then what you need to do? You need to multiply the time with the bandwidth, right? You need to multiply this with bandwidth. So bandwidth into TT plus 2TP. These many bytes you can send, or these many packets you can send. And you can easily see that both are equal in terms of unit only, they are different. Otherwise, if you convert this bytes to the packet, so how you can convert? Can you tell me, or maybe the package to the byte? You just need to multiply by the length, right? If you multiply by the length, then you will be getting this number. You can easily verify. If you multiply by the length, you will be getting this number. In these many packets, these many bytes are only there. Okay. Anyway, this number is same as L into 1 plus 2A. If you check, then you can easily come up with the equivalence, right? Okay. So basically, I'm saying that in this much time, which is the RTT time, you can send either these many bytes or you can send these many packets, right? That's what I'm saying. Hope you understood. Okay. Now you tell me that what is the efficiency in stop and wait? See, how much time you are utilizing? You're utilizing just TT time out of what is given to you, TT plus 2TP, right? This is one way to look at efficiency. You can also look at efficiency as how many you can say bytes you are sending, right? How many bytes you are sending in stop and wait? Just one packet, right? L bytes you are sending. Out of what you could have sent, if in that much time you could have sent this much, right? Which is bandwidth into TT plus, okay, this is 2TP to TP. These many bytes you could have sent. These many bytes you could have sent. These many bytes you could have sent, and you are sending these many bytes only. So that's also the efficiency. You can easily see that these two numbers are same. I mean, L upon bandwidth is transmission time only, right? Now, there are many other ways to look at the efficiency. What is the other way that we have looked at? So we said that, okay, if you want to measure in terms of packet, how many packets you are sending? One packet. How many you could have sent? 1 plus 2a, 1 upon 1 plus 2a. That's also the efficiency, right? You write in this way, you write in this way, you write in this way, everything is same. Okay. Or maybe if I just tell you in terms of, throughput also. So if bandwidth is something, I mean, if bandwidth is, let's suppose 100 bytes per second, then how many in 1 second, how many bytes you could have sent? How many bytes you could have sent? 100, right? In 1 second. But it is not necessary you are sending these many. Maybe because of the limitation of the protocol is saying that, okay, no, you forcefully wait for 10 minutes, then you can't do anything, right? Maybe because of limitation of protocol, maybe because of anything else, how many you actually send? What we call it? The number is called throughput, right? What we actually send is called throughput. So basically, how much you could have sent is basically bandwidth, right? How much you could have sent is basically bandwidth, and how much you are actually sending is called throughput, right? It's called throughput. That's also efficiency. Do you remember that throughput equal to this efficiency into bandwidth? We have derived one formula. Anyone remember? So, I mean, I'm writing it directly. I will also drive it. Don't worry. But is this fine to everyone? Either you interpret it like this, you interpret it like this, you interpret it like this, you interpret it like this. Right? Efficiency is just that how much efficient you are with the given resource. Okay. Everything is actually same. Right? Now, this is the efficiency. Let's just look at the throughput quickly. So what was the throughput? Throughput says that what you are actually sending, right? Sending in 1 unit of time, right? So can you tell me the unit of throughputs? Can I say the throughput can be measured that how many packets you are sending in 1 second? Can I say throughput can be measured like this? Can throughput be measured like this? How many packets you are sending in 1 minute? So this is also the unit of throughput. This is also the unit of throughput, right? These are the units of throughput. Can I also say that throughput can be measured like this, which means how many bytes you are sending in 1 second? I mean, whatever is the unit of bandwidth, it is the unit of throughput, right? Or maybe bytes per millisecond. I mean, anything, whatever is the unit of bandwidth, it is also the unit of throughput. So what you are actually sending is called throughput, right? Okay. In terms of bytes, can you tell me how many, I mean, in bytes per second, how many bytes you are actually sending? In how much time? So in let me write that way. In TT plus 2 TP time, you are sending L bytes. Let's suppose this is in seconds, okay? In these many seconds, you are sending L bytes. Is this okay to everyone? Now, can you tell me, okay, let me write in that way. In L bytes, basically, you are sending in TT plus 2 TP time. Now, can you tell me 1 byte you are sending in how much time? Right? Okay. So I want to write bytes per second. So basically, I think that is the better way to write in bytes per second. So in 1 second, how much you are sending? In 1 second, how much you are sending? L upon TT plus 2 TP, right? These many bytes you are sending. So that's called throughput, right? This is the throughput. This is bytes per second. Can you quickly tell me, can anyone quickly tell me what is the throughputs in packets per second? In the packets per second, how much basically in this much time you are sending? one packet only, right? So it will be in 1 second you are sending 1 upon this many packets. So it will be 1 upon TT plus 2TP, right? These many packets per second, in the packets per second. Is this okay to everyone? Packets per second. So you are sending one packet out of this much time. So that's what we call throughput, right? So you can have the throughputs in packets per second, you can have in bytes per second, anything is fine. Have you understood? So this is also fine, this is also fine. Now let's just quickly compare this throughput with the efficiency. Maybe I can take one of this. So let's just pick this one. See, efficiency is this, right? And what is the throughput? You are sending how much in 1 second, how many bytes you are sending? L. Sorry, in TT plus T, this is TP. In TT plus 2TP time, how many bytes you are sending? L. So in 1 second, you are sending L upon TT plus 2TP, right? So this is L upon TT plus 2TP. This is throughput. Now from here, can we drive the relationship between throughput and efficiency? Can you not say that throughput is nothing but efficiency into bandwidth? Right? Also, isn't it making logical sense to write the like efficiency as throughput upon bandwidth? Is this logical? Yes. Why? Because this is what you are actually doing, what you could have done, right? What you are actually doing. Right? What we could have done. So that's how the efficiency is defined. Okay. Now let's just directly solve the questions. Maybe it will give you the better feeling. Okay. So let's see this question number 1. I think we have also solved this particular question in last class, but still, let's just see for the sake of the slides. So what they're asking, what is the efficiency in stop and wait protocol? If transmission time for the frame is 20 nanoseconds, so the transmission time is given to you is 20 nanoseconds, and the propagation time is given to you is 30 nanoseconds. So what is the efficiency? Efficiency is TT upon TT plus 2TP, which will come out to be 20 upon 20 plus 2 into 30, which is 60, which is 20 upon 80. Now, in terms of percentage, it is 25%, right? So that's why B is the correct answer. Okay. So here, 25% is the correct answer. Understood? Now let's just solve more questions and you will get the better feeling about this particular topic, which is stop and wait, right? Okay. So let's see this question. What they're saying, consider a 1,000-mile link, which means the distance is given to you is 1,000 miles. Of 1 MB, this is bits, I think, right? 1 MB per second capacity, which means they have given the bandwidth. From this unit, you can understand this is the bandwidth. Okay. That is error free, which means there is no error. If the link is used by the single sender sending 1250 bytes frame. So the length is also given to you, which is 1250 bytes. And the bandwidth is also given to you, which is 1 Mbps, right? Bits, which is bits. Can you tell me what is the transmission time here? It will be length upon bandwidth. So into 8 to convert that into the bits, 1 into 10 to the power 6 bits per second. It will be in the seconds. If you want to convert in the milliseconds also, you can convert, right? So just multiply by 10 to the power 3 to convert into millisecond. So what it will be? It will 0, This is, I think, 10,000, right? Which is 10 to the power 4, 7, I think 10 milliseconds, right? So it will come out to be 10. Okay, they want in microsecond if you want. Okay, let's just convert it into microsecond itself. If you convert that into microsecond, then it will be 10 to the power 6, right? I think the other numbers are in the microsecond. So maybe I can convert that into the microsecond. So this will get cancelled out. And then this is 10,000, which is 10 to the power 6, sorry, 10 to the power 4 microseconds. Okay. Now what they're asking, that the transmission time is given, distance and is the velocity given to you. They're asking link utilization. Link utilization is just nothing but efficiency. Okay. Efficiency and link utilization is same. Now they're asking the efficiency, and they have also given the distance, but they have not given the velocity. But seems like they have given the propagation delay, right? Directly, which is 5 microseconds. So the distance is not required to us. The propagation delay is directly given to us is 5 microseconds, which is TP. Can you calculate the efficiency here? It will be TT, which is this one, upon TP plus 2TT, right? So okay, this is per mile. They have given the per mile. Okay. So since they have given the per mile, so that is why I need to multiply by the distance, right? Okay. So which is 5,000 microseconds. Now, given these numbers, can you calculate the efficiency? Let's just calculate it. So what is the transmission delay? This is 10,000 upon transmission, which is 10,000 plus 2 into 5,000, which is propagation delay, right? It is efficiency. How much it is coming out to be? 10,000 upon 2 into 10,000, right? It is coming out to be, I think, this is 10,000 again, 50%, right? Yeah, this is coming out to be 50%. So the 50% is the answer here. Okay. Yeah. Have you understood? So this question from is this university. Okay. Now, let's just move to the next question. So let's just solve this question. What they are saying, consider a 10 kbps link. So bandwidth is given to us, which is 10 kbps, kilobytes per second, with 50 millisecond one-way latency. One-way latency means, can you guess what it might be? It is propagation delay. Yes, it is propagation delay. So 50 millisecond is propagation delay. And length is also given. Since the length is given to be 1 kb, I can find out the transmission time, which is length upon bandwidth. So it is 1 upon 10 seconds, right? Because both are in kb. So in the milliseconds, I can write it 100 milliseconds, right? Okay. Now the frame size is given. Okay, that is fine. So transmission delay is given to be 100 millisecond and the propagation delay is given to be 50 millisecond. Can you tell me the efficiency? Transmission delay upon transmission delay plus 2 into propagation delay. So I think it is also coming out to be half, right? It is also coming out to be 50%. Okay. So this question and this question, okay, are from different universities. Okay. So they have given the solution like this with the frame size of 1 kb. Whenever sender sends a frame, it should wait until receiving the AC key from receiver. So in ideal case, the time needed for each frame is, time needed for each frame is TP plus 2TT, right? TT plus 2TP. TT plus 2TP. So which is 100 plus 2 into 50. So it is 200 milliseconds. I mean, till it gets the AC key also. For every frame, it will take this much RTT, right? This is RTT. So yeah, therefore we can send. So 200 millisecond, in 200 millisecond, how many we are sending? Okay, suppose they ask you the throughput here. Can you calculate the throughput? See, to calculate the throughput, either you can multiply efficiency and bandwidth and you can get the throughput. What is the throughput? If you multiply efficiency and bandwidth, then you will be getting 5 kbps, right? So the throughput will be, you can definitely calculate the throughput. It will be 5 kbps, right? But you can also find the throughput without the formula, in the sense that, see, they have given you this data, right? So let's just try to find out the throughput without any formula. Formula in the sense, without going through the way of the efficiency. See, you can calculate the efficiency and then finally you can find out the throughput. That is one way. Another way is to directly see that, okay, what is RTT? And in RTT, how much, actually in stop and wait, we just send one frame. So one frame. So what is RTT here? So you can calculate the RTT, which is TT plus 2TP, which is coming out to be 100 plus 100, right? In this case, because it is given to be 50 millisecond, right? This number is 50 millisecond. So that is why it is coming out to be 200 milliseconds. Now, once you know the RTT, can you not directly tell me the throughput without calculating the efficiency? I mean, you can calculate the efficiency, that's not an issue, but you can directly calculate the throughput also. What is the throughput? Throughput is, in this RTT, how many packets you are sending, or how many bytes you are sending in terms of bytes? One KB, right? Yeah. So what is the throughput here? Throughput is bytes per second. So basically, in 200 millisecond, you are sending 1 KB. Or maybe in other words, I mean, if you want to convert, you can convert that in the seconds. Okay, let me do first this way, directly with milliseconds. Or maybe I can also convert in the second, because everything in the second. So can you tell me how many seconds it is? 200 upon 1000, 1 by 5 seconds, right? Okay. Or maybe I can write 0.2 seconds. So in 0.2 seconds, you are sending how much, how many bytes? One frame, right? 1 KB. In 1 second, you will be sending 1 upon 0.2 KB, which is coming out to be, this will be 5, right? So kbps. This is second. So this is 5 kbps. Is this okay to everyone? See, how we are calculating throughput is that we know that, okay, this is the RTT. In this RTT, how many frames we are sending? 1 frame only. What is the length of that? 1 KB. So in 1 second, what we will be doing? That's the throughput. Or in other words, you can say here, if 200 milliseconds you are sending, just find out in 1 second what you are doing, right? If in 200 milliseconds you are sending, let's suppose 1 KB. Which is same as saying, can I not say, this is same as saying that you multiply by 5 both sides. Can you not say that in 1000 milliseconds, which is in 1 second, you are sending how many? 5 KB. Just multiply by the 5 both sides. Right? If you multiply 5 here, it will be 1 second. If you multiply 5 here, it will be 5 KB. So in 1 second, you are sending 5 KB, which is the throughput, kbps. Right? So either you find the throughput like this, which is also 5 kbps, by multiplying the efficiency, or you can directly say that, okay, in RTT, what is the length? I mean, how much you are sending? That's the throughput. Then in 1 second, what you will do, right? Just find out that in 1 second, what you will do. That's the throughput. If in 200 milliseconds, you are sending 1 KB, then 1 second, what you will be doing? 5 KB. That's the throughput. So that's what they're saying, that in ideal case, okay, 200. Therefore, we can send maximum 5 frames in 1 second, right? We can send maximum. I mean, this is the throughput. Whatever we can do is throughput. I mean, in this particular protocol, we can send 5 frames in 1 second. So that's the throughput. So 5 KB of the data in a second, therefore the maximum. So what they are doing, they are basically doing the interesting thing. They are finding the throughput, and then they are dividing by bandwidth. They are using this formula. They first found out the throughput, which is 5 kbps, 5 KB of the data, right? We can send 5 KB of data. But what we could have sent, I mean, what we are actually sending is 5 KB, but what we could have sent is 10 KB. So that's how they are finding the efficiency. They are using this formula, which is okay. Have you understood what they are doing? So they're first finding out the throughput. What is the throughput? Throughput is what we are doing in 1 second, right? I mean, how much bytes we are sending in 1 second. So see, the RTT here is coming out to be 200 milliseconds. You just tell me in 200 milliseconds, how many bytes you are sending? 1 KB, isn't it? Because 1 frame you are sending in stop and wait. Now, in 1 second, how much you will be doing? That's all. Just multiply by the 5 both side, which is 5 KB. In 1 second, you are sending 5 KB. So what is the throughput? Now, can you tell me the throughput? Throughput is 5 kbps. Because what you are doing, how much bytes you are sending, actually sending in 1 second is throughput. Now, what they did to find out the efficiencies, they are saying that what we are actually doing in 1 second and what we could have done. So 5 KB, what we are doing, throughput upon bandwidth, basically they are doing this. That's how they are finding out the efficiency, right? Which is also coming out to 1/2. So there could be multiple interpretations, but the idea is same, which is that, I mean, the fundamental ideas are same, that in throughput, we just say that, okay, in 1 second, what we are doing. So for our questions, we will just follow the simple method, which is that finding the efficiency like this only. Okay. If they ask you the throughput, then either we can multiply by the efficiency with the throughput, or we can directly find the RTT. And in RTT, what we are doing is actually the throughput, right? Okay. Have you understood this way? That using the formula, you just find out this efficiency using this formula. And then if they're asking the throughput, then just say that, okay, in RTT, how much you are sending? Then based on that, in 1 second, what you will be sending is a throughput. Or maybe you can directly multiply efficiency and bandwidth, and then you can find the throughput. Okay. Cool. Now let's solve this question, which has been asked in GATE 2015. So what they are saying, a link has transmission speed of 10⁶ bits per second. So they have given transmission speed. So what do you think? What it is? This is bandwidth, right? So bandwidth is given to you is 10⁶ bits per second. Now, if it uses the data packets of size 1000 bytes, which means L is 1000 bytes, it is in bytes. Assume the acknowledgement has negligible transmission delay, and that is the propagation, and that its propagation delay is same as the data propagation delay. Yeah, that's what we generally assume. Also assume the processing delay. Yeah, that's what we assume, that processing delay are negligible. The efficiency of stop and wait setup is exactly 25%. So efficiency is also given to us, which is 1/4. The value of one-way propagation delay, which means they are asking one-way propagation delay. Can you understand what does this mean? They're asking for TP. So in milliseconds, they're asking. So they have given the efficiency. Now the TT will be length upon bandwidth. So 1000 into 8 upon bandwidth is 10⁶. That ultimately will be in the seconds. They're asking things in the millisecond. Let me multiply by 10⁶. So this is 8 milliseconds. Is this fine to everyone? Okay. So this is 8 milliseconds. Now efficiency is given to you. Okay. So I will do that in the next page, so that if you are seeing it later, then first what you can do, you can attempt the question by your own, and then you can see the annotated notes, right? So does these things help? Like, I mean, first this question is shown to you without any solution, and then there is a solution, right? So this is better way. Okay. So now the efficiency is given to you is 1/4, and the transmission delay is given to you is 8 milliseconds. They're asking for the propagation delay. Can you quickly solve this question? So this is TT upon TT plus 2TP is 1/4, right? Okay, so maybe I can write 1 upon 1 plus 2a here, which is 1/4, and then 1 plus 2a is 4. So 2a is coming out to be 3. So a is coming out to be 3/2, and A is nothing but TP upon TT equal to 3 by 2. So TP will be into 8. So TP will be, which is 12 milliseconds, right? Okay. So let's see the solution provided by Arjun sir. So what they're saying, that in stop and wait, the frame is sent and the next frame will be sent only after ACK is received. So efficiency is amount of data sent upon amount of data that could have been sent. Yeah, nice. So see, I told you the interpretations of efficiency, right? I mean, you can interpret the efficiency in any way. So Arjun sir here is interpreting in terms of the data. And you can also interpret in terms of the time also, right? Nice. So amount of data we are actually sending is just 1 byte. Sorry, just L bytes. L is the length of the frame. And the amount of data that we could have actually sent is nothing but RTT into bandwidth. Is this okay to everyone? That how they're writing this number? RTT into bandwidth? Let me know. The amount of data that we could have sent in RTT time is just multiplied by the bandwidth. I think we have done this many times now, right? This is RTT into bandwidth. Okay. Propagation. So RTT is nothing but propagation delay for the data, propagation delay for ACK transmission, and so on. So, okay, you can find out the efficiency in this way also. I mean, the propagation delay in this way also. Okay. Now let's solve this question. What they're saying, a channel has bit rate of 4 kbps. So like this is bits. Okay. So they're saying bit rate is this. What does this mean? They must be talking about the bandwidth, which is 4 into 10 to the power 3 bits per second, right? Bits per second. And the propagation delay they have given is to be 10 milliseconds. For what range of frame sizes does the stop and wait protocol gives you the efficiency of at least 50%? So efficiency is given to you is 1 by 2 and propagation delay given, length is not given. Can you solve this question? So what will be the answer here? The length is not given and they're asking for the length only. So you can say that 1 upon 1 plus 2a is given to you is 1 upon 2, which means 1 upon 2a, 1 plus 2a is given to you as 2, which means a is 1 by 2, which means TP upon TT. So TP upon TT is this. So TT is 2 into TP. And from here, we can find out that length should be 2 into TP into bandwidth. Right? So what should be the length? This is 20 milliseconds. But if you multiply by the 10 to the power minus 3, it will be in the second. And bandwidth is 4. I think this will be 80 bits. Okay. So it should be 80 bits. Okay, they're saying at least 50%. So at least means this efficiency is greater than or equal to 50%. Right? Greater than or equal to 50%. I mean, everywhere you just write, I think, greater than or equal to. So it will be less than or equal to. Anyway, you can work with this, right? I think again, this will be greater than or equal to because I'm using that. It will be greater than or equal to, right? So the length of the frame should be greater than or equal to 80 bits. Yeah. So the frame size is greater than or equal to 80 bits. Right? This is the transmission delay. And after that, anyway, this is the diagram that they have shown. Is this okay to everyone? So basically, you understand here that if you want to achieve some efficiency, then what is the way to achieve the efficiency? The way here is that, I mean, in the stop and wait, we first transmit and then we wait for the propagation, right? We wait for the propagation. So here I can say that I mean, one of the way to achieve the better efficiency is that, I mean, here, if let's suppose if I want to achieve the better efficiency, then what we can do, we can keep on sending the frames, right? I mean, instead of waiting for the acknowledgement, we can keep on sending the frames. Here also we keep on sending the frames. This is one way to achieve the better efficiency. Is this understood to everyone? But that's what we cannot do in stop and wait, obviously, right? In stop and wait, we send one and then we wait. So we cannot keep on sending, that is for sure. So to achieve some good efficiency, what we do, let's suppose this is some sender and this is one receiver. I mean, that might not be a good way, but yeah, for the stop and wait, that's what we are saying that we do, right? Now, suppose you want to send some frame. So instead of sending this frame and waiting for a long time, what we do, we say the frame is too long. Okay, if the frame is too long, then this frame itself we keep on sending, right? We will keep on sending. I mean, if the frame is too long, then basically the efficiency could be little better. Are you getting my point? Instead of sending the small frame here, see, the one idea is that we can send multiple frames. But if we cannot send multiple frames, then intuitively we can say that it is better in the stop and wait that we send the large frames. Okay, if frame size is at least 80 bits, then the efficiency is at least 50%. Right? So here the efficiency is dependent on the frame size. Have you understood? Yes, RTT will also increase. It's not like that we will not be waiting. It's just like that that at least we can send some good amount of frame. That's what I'm saying. Yeah, RTT will also increase. That is fine. Yeah, I agree with you. Efficiency is 1 upon 1 plus 2a, right? 2 into TP upon TT. So this is same, but if you increase this length, this is basically length upon bandwidth, right? If you increase this, then this total number will decrease, then efficiency will increase. Okay. In stop and wait. I mean, this is a normal takeaway that you can see from here. Anyway, but that's not what must required. Have you understood this question at least? Okay. Now let's solve this question that has been asked in GATE 2005. So what they're saying, a channel has bit rate of something, and one-way propagation relay is this. They are using stop and wait. The transmission time of the acknowledgement frame is negligible. To get the at least 50% efficiency, what is the minimum frame size? Can you do this question? Should I put it as homework or you want to do it now? Okay. So let's just put it as homework. You can do it, right? The answer is on the next page. You can definitely see and check what is the answer you're getting. Okay, sorry, I forgot to put the heading here. This is also the GATE question, GATE 2015 question. Okay, I mean, I forgot to put the heading, but that is fine. Okay. Yeah, let's just see this question, which has been asked in GATE 2015 inside one, which is question number 53. So what they're saying, suppose that stop and wait protocol is used with the link rate of this much. Assume the transmission time is negligible. The minimum frame size they're asking to achieve the 50%. Okay, I think this also you can do as an homework. Is this okay to everyone? Okay. So the answer is on the next page. You can definitely try. This is also the easy question. Let's see this particular question. Now what they're saying, consider the packet size are 1000 bits. Transmission rate is also given. So the packet size means the length, right? Length is 1000 bits. Bandwidth is given. Transmission rate means here, what do you understand from this transmission rate? Transmission rate is basically the bandwidth, right? 1 Mbps. And the propagation delay is given to you is 15 milliseconds. Can you also find out the transmission delay here? Length is 1000 upon bandwidth is 1 into 10 to the power 6. That will be in the seconds, right? that is in bits, so that is fine. So that will in a second, but let's just find out in the milliseconds. So what is the answer here? 1 millisecond, right? Now assume the acknowledgements are very small, the processing time is also negligible, and there is no errors in the transmission. What is the throughput if we use stop and wait? Yeah, that's the question that I want you to solve. Solve this question in 2 ways. One is find the efficiency, and then throughput will be efficiency into bandwidth. This is one way to solve this question. Also, if someone asks you the throughput, then how you can do? Just find out what is the RTT. In RTT, how much you are sending. Then in 1 second, how you are sending, how much you are sending. So just find out the throughput using both the ways, not just only one way. Okay. So find out using the efficiency, find out directly. Can you do this question now? Okay. So what is the answer you're getting? Let's just see. So see here that what we are saying is transmission time is given to you as 1 millisecond, and the propagation time is also given, which is 15 millisecond. So the transmission time is 1 millisecond. The propagation, transmission time is 1 millisecond, and propagation time is given to you 15 milliseconds. What is RTT here? 15 plus 2, TT plus 2 into 15, right? Which is 31 milliseconds. Okay. In this, how much bytes you are sending? In 31 milliseconds, you are sending 1000 bits, right? So you are sending 1000 bits. So in 31 milliseconds, you're sending 1000 bits. So in 1 milliseconds, how much you're sending? 1000 upon 31, right? And then if you want to find out in 1 second how much you're sending, then you just multiply. So this is in 1 millisecond, right? So in 1 second, you need to multiply by the 1000, right? So if in 1 millisecond you are sending this, which is, okay, this is bits per millisecond. Yeah. So basically this is bits per millisecond. Now, if you want to find out bits per second, then you need to multiply by the 1000, not the divide, right? So it will be, or maybe let's just have in bits per milliseconds, right? So this is 1000 upon 31. So what is the 1000 upon 31? Can you tell me? This is 32.26. Let's just keep it 32.258. Okay. 32.258. 258 bits per millisecond. So what we can do, we can also write in bits per second, right? Or maybe bytes per second if you want. So what is the bandwidth unit? Bandwidth, they have given bits per second. Okay. So let's just write in bits per second only. So to convert into bits per second, should I be multiplying by the 1000 here, this number, or should we dividing by the 1000? See, this is milliseconds. For this milliseconds, you need to, for this millisecond, you need to basically multiply by 10 to the power minus 3. So ultimately, you need to, this is 32 bits per milliseconds. So now to convert this millisecond to the second, what do you need to do? This millisecond is in the denominator. What do you need to do? To convert the millisecond into second, you need to multiply by 10 to the power minus 3. Right? So which means that ultimately you will be multiplying by 10 to the power 3, right? So I think this is 32 bits. 32 into 10. That's also the common sense that if in 1 millisecond you can send this, then in 1 second you will be sending into 1000, right? So So in 1 second, you will be sending more data. So if in 1 millisecond you are sending this, then in 1 second you will be sending more data. This will be 32.26 into or 258. Or maybe let me write 32258 bits per second, which is the throughput, right? That's the correct answer. Okay. Cool. So if you want, you can find out the throughput using efficiency also. So what is the efficiency? Efficiency is TP upon RTT, which is 31. This is the, sorry, TT, which is 1 upon 31. This is the efficiency, right? And now what is the bandwidth? Bandwidth is 1 Mbps, 10 to the power 6 bits per second. So what is the throughput? Throughput is bandwidth upon bandwidth into efficiency, which means this. If you do that, then what you're getting? I mean, you will be getting the approx the same number. Okay. So 10 to the power 6 upon 31. 32258, right? Something like this. Okay. So either you do using this method, which is the second way, or you do directly using the RTT. Okay, this is the first way. Which one you will be preferring? What do you think? Which one you will be preferring more in case of throughput? In case of efficiency, directly go with the formula. In case of throughput, which one you will prefer? Any random guess? You might say that you will be preferring the second way. I mean, currently you might say you will be preferring the second way, but let me tell you that the more questions we will be doing today, you will be convinced that this first way is good enough. Okay. I mean, you don't need to first calculate the efficiency, and you don't need to do that. Okay. The first way is actually the good enough. Okay. You will be convinced by the end of this lecture. Okay. So now let's solve this question, which is question number 9. Now, this question has been asked in GATE 2016, and I want you to solve this question. Let me just walk you through the midway of the question, okay? I mean, let me just read out the question for you, but I want this question to be done by you completely without any help from my side. Are you ready? This is a good question, but you should be ready, right? Okay. So the sender uses stop and wait protocol. Frames are of size, so length is given to you, which is 1000 bytes. And the transmission rate at the sender side, transmission rate means here the bandwidth, right? It's given to you, which is 80 kilobits per second. Size of the acknowledgement is given to you is 1000 bytes. Oh, nice. See, till now we just have the data sizes, but they have also given the size of the acknowledgement. This is nice. This is the length of acknowledgement, right? It is given to you 100 bytes. And the transmission data, the receiver is given to you is 8 kbps. Okay. So the transmission rate at the receiver, which means that you are using two channels, it seems, A to B and B to A. So whenever A wants to transmit, it seems that A can transmit with 80 kbps speed. But whenever B wants to transmit, it seems that it can transmit with 8 kbps speed only. Okay. The bandwidth at the B, maybe it is the B which is slow, maybe the channel is different, or maybe there could be many other reasons, but the bandwidth is different at both the sides, right? Now the acknowledgement size is also given, and then they're asking the throughput. Okay, this question you can do, but let me first do one question that I wanted to do. Okay, just give me 1 minute. I think I wanted to solve it here only, but somehow I have it here. Okay, so let me first solve this question. This is in GATE 2016. This is question number 18. Okay, Actually, that question I have already planned later on. I don't know how I put in between. Okay. Anyway, this question I planned for later on because I wanted to solve one question before that. So let's just do one thing. I mean, we can do this question uh, after a while. Is this okay to everyone? Okay. I planned it for the later slides. So somehow I put it in between, but I planned it for the later slides. So I will come to this question in a minute. Okay. In a while. Now let's just first do this question. So consider the following chain topology. Now they are saying A to B, B to C, C to D, and D to E. Cool. Now A is sending package to E using the reliable transport protocol. Okay, I mean here you don't worry about this transport protocol. It is not needed to solve the question. Each link can transmit one packet per second. So the bandwidth is given here in terms of the packet per second. This question is from MIT. Okay, the bandwidth is given to you in terms of question in terms of packets per second. So for each link, it is one packet per second. There are no queues or other sources of delay at the nodes except the transmission delay, of course. Okay, so they're transmitting. That is the only delay that you have. Otherwise, there is no delay. Now they're asking what is the RTT between A and E. So RTT involves a total time, right? I mean, if you send some packet, then till the moment you receive the acknowledgement. So if you're sending some packet, then it is given that the bandwidth is given one packet per second. So what is the transmission time? Can you tell me? Can you tell me the transmission time here? 1 second, isn't it? Why? The length is one packet. Okay, length is one packet. Upon the bandwidth is also one packet per second. So if you divide the length and bandwidth, the transmission time will come out to be 1 second. So they're saying or other source, there is no other source of delay. So currently consider that propagation delay is also zero, also negligible. So what is the RTT? Can you tell me? A is sending packet to E. Except the transmission delays. Okay, they have given it to be 8 seconds. Actually, the acknowledgement, they have not said anything, right? Sending package to E using the reliable transport protocol. Each link above can transmit one packet per second. So 4 seconds you will anyway take from here to here, A to E. I think they should also give the acknowledgement about the acknowledgement, right? How much the acknowledgement is taking, right? Each link can transmit it. There are no queues or other source of delays at the nodes. Either they should give the acknowledgement delay or something like that, right? So let's just consider that they are saying about the acknowledgement delay. Okay, so let's just consider the acknowledgement size is also same as I mean the acknowledgement transmission time is also the 1 second only. Okay, then only the RTT will be 8 seconds. Okay, anyway, this question I have put just for the sake of understanding one thing which you will get to know. So here, I mean, they have given the answer as 8 seconds. The region could only be that they are considering that the acknowledgement is also taking some transmission time, which will be, let's suppose, that is also 1 second. So total 8 seconds you will be taking in that case, right? If that is the case, that in 8 seconds you are just sending one packet, then can you tell me what is the throughput? If in 8 seconds you are just sending one packet, then what will be the throughput? Throughput will be one packet, or maybe in 8 seconds, you are sending one packet. So in 1 second, how much you can send? In 1 second, you can send 1/8 packets per second, right? Okay. So for this B, 1/8 is the answer. Considering that RTT is 8 seconds, they should also give, I think maybe there is more context in the lecture that they have taken. Okay. So they might be considering that, okay, acknowledgement and the data is having the same transmission time. Okay. Cool. So in that case, the RTT is 8 seconds, and then the answer is 1/8 packets per second. Now let's solve this question. So what they're saying, host A and B are connected connected to each other by a router R. Okay. So A and B, they are saying that they are connected by a router R. R is a store and forward router. The bandwidth from A to R is 10 Mbps. From A to R, this bandwidth is given to you as 10 Mbps. From R to B, the bandwidth has been decreased, which is 5 Mbps. The one-way latency of each link is 22 milliseconds. Of this also 22 milliseconds. Assume that host A sends 30 KB file to host B. Assume the file is divided into two packets, P1 and P2. P1 has length 10 KB, and assume the packets are sent back to back. So if that has been divided into two P1 and P2, P1 is having length how much? 10 KB. So what is the length of P2? P2 must be having the length of, if the total file size is 30 KB, can you tell me? If P1 is having 10 KB length, then P2 must be having the length of 20 KB, right? So they are saying with this following data that you are sending two packets back to back, P1. Okay. So this is not directly stop and wait question because you are sending back to back, right? Back to back means there is no stop and wait. So P1 की length है 10 KB and P2 length is 20 KB. You are sending back to back, right? That's fine. Now, what is the difference between the arrival times of the first and the second packet at host B? At host B, at what time the first packet will reach and at what time the second packet will reach? Okay, can you solve this question? So what is the transmission time for the packet 1? For P1, what is the transmission time? Length upon bandwidth. What is the length? 10 KB bytes, right? Upon bandwidth. I mean, transmission at A, basically at A. Okay. It will be 10 Mbps. This is bits. So that's why let me multiply by 8. This is 10 to the power 6. This is 10 to the power 3, right? So I can convert that to mega itself, right? Okay. So now I think the units are fine. So this 10 and 10 will get cancelled out. So it will be 8,000 seconds, which is just 8 milliseconds. Okay. So you can find out that transmission time is 8 milliseconds for the packet 1 at this A. Now for the same packet, if the bandwidth is half, then what will be the transmission time at B? Sorry, at R. If the bandwidth is half, then the transmission will take double time, which means the 16 milliseconds, right? It will be 16 milliseconds. So at A, the transmission time is 8 milliseconds. At R, the transmission time will be doubled. What about the packet 2? For P2 at A and at R, what is the transmission time for P2? If you compare, the length has been doubled here, right? If the length is doubled, then transmission time will be doubled. So it will be 16 milliseconds. And similarly, here the bandwidth is half, which means the transmission time will be again doubled, which is 32 milliseconds. Okay. Yes, 16 and 32. So that's what I think we already did in one of the lecture, right? Okay. Now, these are the transmission time for A, for P1 and for R, for P1 and P2. Okay. Now, how much time it will take for P1 and how much time it will take for P2 to reach at B? And what is the time difference in arrival times? Can you see now? See, 8 milliseconds it will be taking from A. And basically, this packet P2 is 8 milliseconds far from this this packet P1. I mean, P2 will be here and P1 is itself on the link, right? Okay. So basically the already delay is 8 milliseconds. Now, what will be happening? It will get transmitted in 16 milliseconds. So maybe I can solve this question. See what is happening here. From t equal to 0 itself, if you compare from t equal to 0 itself, right? So these kind of things we have already done. Now let me do it again. For P1, from t equal to 0 itself. In how much time it will reach to B? It will first get transmitted in 8 milliseconds from A, then 20 milliseconds it will get propagated, and then it will get transmitted from here, which is 16 milliseconds, and then 22 milliseconds. From t equal to 0, this is the time that it will completely reach to B. What is the time that P2 will completely reach to B from t equal to 0 itself? 8 milliseconds, it is anyway waiting. Right? 8 milliseconds, it is anyway waiting for this packet to get transmitted. Then 16 milliseconds, it will take for himself to get transmitted. Then 20 milliseconds, 22 milliseconds, then 32 milliseconds it will take, and 22 milliseconds, right? Is this fine to everyone? I mean, to reach to B. So if you see, then this the propagation delays will get cancel out. And then you will say this is the total transmission time for packet 1. This is the total transmission time for packet 2. So, and 8 milliseconds it is anyway waiting. So if you just see, then, I mean, you can just cancel out this 8 and 8 and 16 and 16. So 32 is coming out to be the final answer, right? The difference is 32 milliseconds. So the arrival time differences will be the 32 milliseconds. So you can say arrival time difference is 32 milliseconds. Is this fine to everyone? Let's just check the answer. Yeah, 32 milliseconds is the difference in the arrival time. Okay, so Siddharth is asking. Okay, Shivam is asking, sir, how P2 will take 8 milliseconds? No, P2 is this 8 milliseconds just waiting. From t equal to 0, it is just waiting. I'm assuming that, okay, from very start, it is just waiting for 8 milliseconds to get transmitted for this. Okay. And then 16 milliseconds it takes for the transmission time. Then it get propagated, then transmission, then got propagated, right? Okay. I hope that is fine. Okay. So this is the answer here. Now this has been done, which is coming out to be 32 milliseconds. Let me know if that is okay to everyone. This particular part A, the difference in arrival times. Is this okay to everyone? Okay, so have you understood this? Now let's just see the question number B, which is saying how long it will send the entire file. So how long you want to send 2 packets, right? This is also a very interesting question. We have also done this question, but let's just do this again quickly because today I want to ask something else. Okay, which is the throughput. So let's just do this part B also. Okay, for P1 at A, the transmission time was 8 milliseconds, and at R, the transmission time was 16 milliseconds. Now, what they're saying, if you want to send the entire file, then how much time you will be taking? Can you calculate this? Okay. Can you quickly check if there is a queuing delay? How to check the queuing delay? First of all, tell me, is there any possibility of queuing delay? See, the links are different, right? Links are different. So the transmission time is different. So maybe there is a possibility. So at R, for packet 1, at what time from t equal to 0 it will be leaving R? 8 milliseconds it will be taking, then 22 milliseconds it will be taking, and then 16 milliseconds this will be taking to transmit from R. So at this time it will be leaving R. For P2 from t equal to 0, at what time it entered into the R? 8 milliseconds it is waiting, 16 it will take to transmit from here, and 22. So it will be entering into the R at this time. At that same time it is leaving the R. So tell me, is there any queuing delay here? There is no queuing delay, right? So, have you understood why there is no queuing delay? P1 leaving R, P2 entering R, right? Okay. Let me know if that is okay to everyone. Okay. Now you want to check that how long it will be taking. Since there is no queuing delay, you can just check using the last packet method. Do you remember that method? So do you want to solve this question quickly? So you can check that how long you will be taking. What is the total transmission time for all the packets? It will be 8 plus 16, right? 8 plus 16 is total transmission time for both the packets. And then the last packet will take how much time? 22 milliseconds from here, and then 32 milliseconds from here, and 22 milliseconds from here. So this is the total time, which is coming out to be 100 milliseconds. Okay, how much it is coming out to be? 100, yeah. Right? You can sum this up. Is this fine to everyone? Okay, so that's what we have already done. And we have also solved many PYQs here. Now, what is the throughput between A and B? This is interesting. Can you calculate the throughput now? So how much time you are taking for any file to send from A to B? This is not a stop and wait. It is just the total time they are saying 100 milliseconds. Okay. There is no acknowledgement, let's suppose, not required. Okay. Nothing is required, let's suppose. Okay. This is not a stop and wait, and there is no acknowledgement system or something. Right. Okay. So in this case, can you tell me what is the throughput? If you're taking 100 millisecond for how long file? What is the size of file you're sending? 30. So which means that you can say that this 30 into 10 to the power 3, these many bytes you are sending in 100 milliseconds, right? In 100 milliseconds, you are sending these many bytes. So which means in 1 second, you will be sending 10 to the power 3. You can multiply by the 10 to the power 3. You will be sending this much file. Okay. So 30 KB upon this. So if you change the unit, you will be getting, this is the answer. See here, 30 KB you are sending, which means KB means, okay, they are having in mega. So let me write, okay, first let me write in 30K. This is capital B, right? Size of the file is in the capital B. Okay. So 30 KB you are sending in 100 milliseconds, right? So this is the throughput. Let me convert that into the mega bits. So if you convert that into mega, you need to multiply with 10 to the power 3 into bits, 10 to the power 8, 100. If you want to convert that to seconds, then 10 to the power minus 3 actually. Okay, minus 3. So it is coming out to be, or maybe let me just have in the bytes itself for now, just for a minute. Then it is coming out to be 10 to the power minus 6. This will be 0.3 megabytes per second, right? Which is this one. This is megabytes. This is second. Okay, you convert this kilo to mega, 10 to the power 3, milliseconds to second, 10 to the power minus 3. So finally, this is the answer. Have you understood this? Okay. Yeah. Now let's solve this question. This question is from Berkeley University. Let's just see that what they're asking. So they're saying you want to transfer a file from Berkeley to Los Angeles. And for this problem, assume this following. Okay, they have given too much of information. Let's just read it quickly. And they are just asking small questions, but the information seems to be too big. The size of the file is this much. Okay, it will be transferred in 1500 bytes packet, of which 14 bytes are taken for the header. Okay, so they're saying that file size is 12200 bytes, right? Out of which they are saying that, they will be transferred into each packet of size, how much? 1500 data bytes, right? And out of which basically 40 bytes are header. So in fact, this is 1460 bytes packet. This is the file size, and each file will be divided into 1460 byte packet, right? So 1460 bytes plus the 40 byte is the header. Later on, we will be appending it. Okay, cool. The size of the acknowledgement packet is 40 bytes, including a header, and every packet is acknowledged. So they are also saying that this is the size or the length of the data. They're also saying the length of ACK, including the header, they are saying it is 40 bytes. Okay. And length of the data, basically including header, I can say, actually I need to find out the including header only, right? This will be, can you tell me how much it is? 1500 bytes, including header. Okay. These informations are including header. Now the communication is bidirectional and the bandwidth is 12 Mbps. In each direction, host can send and receive at the same time. The latency from the Berkeley to Los Angeles is 12 milliseconds. Okay, and that is the same latency in the opposite direction. So they have given the bandwidth also, which is coming out, which is given to be 12 Mbps, megabits per second. They have given the propagation time also in both the directions. It is also given to be 12 milliseconds, something like that, right? Assuming the time to process a packet is very small, okay, no process time, so the receiver can send the acknowledgement as soon as it receives the packet, but not before it receives the entire packet. Yeah, that is for sure. Assume no packet loss. Okay. So with stop and wait, how long it will take to transfer the file with the stop and wait? So this is a question which we are doing with stop and wait, which means you are not sending back to back. So how long it will take to send basically the entire file? Let's just quickly calculate it. This is a good question, right? So, by the way, how many packets are there? So I think 8 full packets, right? 8 full packets. So the data that we are sending from A to B is basically 8 packets of size 1500 bytes, right? 8 packets of such size. And what is the remaining bytes? See, if you multiply this 1460, you don't need to include the header because header will be appended later, right? Then it is 11680. Okay, 12200, right? 520 is remaining. Okay, so 8 packets of this size and 1 packet of how much size? 560, right? Because 40 bytes of header. Is this okay to everyone? 560 bytes. This is 1 packet. So this much data we want to send. Okay. Now they are saying other information which is given to us is something like this. Can you tell me what is the propagation time which is given? This is the propagation time, right? Okay. So let me just copy this data on the next page and let's just see if we can find out the other numbers here. So by the way, is this okay to everyone that we are sending 8 packets of this size plus 1 packet of this size? Is this okay to everyone? You just need to divide this I mean, you just need to basically check that this 122200 should be, can you quickly verify whether it is correct? This should be 1460 into 8 plus 520 into 1. Can you quickly check, anyone, if this equation holds? Okay, this must hold. Now, okay, that's great. So now basically we are sending with this much data in that proportion. Now let's just see that how much total time we will be taking with stop and wait. Okay, we are not sending. I think this is the very first question we are doing, where we are asking the total time with stop and wait, not the back to back. Okay, so what is the time for the full data if we are sending, a complete packet? Complete packet means the size here is 1500. So the length is 1500. So the transmission time for the complete packet will be length upon bandwidth, right? It is in the bytes and bandwidth is in the bits. So let me multiply by the 8 upon 12 bits, mega times power 6. Okay. And then this is bits per second. So finally, this will be in the seconds, right? Okay. So these many seconds is the transmission time for the complete packet. Is this fine to everyone? It is coming out to be, how much it is coming out? Is this the good number? Okay, this is coming out to be 1 millisecond. That's good. So this transmission time for one packet, if it is a complete packet, is coming out to be 1 millisecond, right? Now, what is the propagation time? That is also given. Let's just also find out the, for the partial packet or something like that. For the partial packet, let me write it partial packet. What is the transmission time? Let's just also find out that transmission time, right? What it will be? It is the length. It is given to be 560 or 520. 560 bytes, I think we are sending, right? Upon 12 into 9^6 seconds. So is this also a good number? No, that's not good number, right? Okay. So 516 into 8 divided by 12 is coming out to be 377.33. Okay. So, let's just keep this number as it is. We will solve it later if required. So we know the transmission time here. We know the transmission time for the partial packet. Now, can you tell me how much total time you will be taking from A to B? Let's just find out from total time from A to B for the 8 packets, which is full, and 1 packet, 8 full packet, and 1 packet, which is partial. Let's just calculate this. See, the total time you need to calculate. Can I just say that, okay, how much total time you will be taking the transmission? Can I just write all of that as once? Or should I follow stop and wait? I think we need to follow stop and wait, right? Let's just find out for the first full packet, how much you will be taking. So you will be transmitting the first full packet, TT, okay? The full packet, for the full packet I'm writing. First you will be transmitting it. And then what you will be doing? You will be asking it to propagate, right? And then what you will be doing? This will get propagate. Then it will transmit the acknowledgement. The acknowledgement also is taking some time to the transmission, because the acknowledgement length is also given. Then what you will be doing? It will again propagate. So this is the total time for the full packet. This is one full packet. If you have 8 such full packet, what you need to do? You need to multiply by the 8. See, this is not the pipeline here. Okay. This is not the pipeline, which means it's not like you cannot transmit all the packet at once. Is this okay to everyone? Right? You need to multiply by the 8 after the full, after the time of first full packet. So for 8 full packets, you will be taking 8 into this much time, TT plus TP plus TTACK plus TP. Is this fine? Now let's just calculate for the partial packet how much you will be taking, and you can easily calculate for the partial packet. I mean, the idea is same here, only this number will be different, right? So maybe I can write it as TT partial plus TP. The propagation delay is same. The ACK is same for both of them, plus propagation delay is again same, right? So this much total time, you need to add both of this and then you need to get the total time. Okay, we can see the solution, but I hope that conceptually everything is fine to everyone. So see, 12 milliseconds, and this is coming out to be 1 millisecond. So for the data, TP plus TT is 13 milliseconds. For the partial packet, okay, this is 820 bytes. Why that is 820 bytes? This is 122,000. Okay. Can you check it? I mean, this is just a calculation. 122. Oh, sorry. This is 000. Okay. Anyway, so this is 122,000, right? Okay. By mistake, I have taken 00, but that is fine. This is 820. This is 83, right? 83 or what? 83. Okay. This is 860. Okay, that's the only modification that we needed, because we have not done any other calculation. Okay. Anyway, let's just see that what they're saying. So the transmission time for the data, the total time which is including for the data is TP plus TT they are writing. This is 12 milliseconds plus 1 millisecond that was fine to us. So 13 milliseconds. Similarly, you can find out for the partial time. I mean, for the partial data, what you are taking. For the acknowledgement also, you can find out the transmission times. Okay. So it seems that, let me write these numbers. For full packet, if it is full packet, let me write these numbers and then we can check. The transmission time, do you remember what we were getting? The transmission time was 1 millisecond, right? And similarly, you can find out for the partial packet. It is not a very nice number, but that is fine. The transmission time we are getting is here 0.573. Okay. And similarly, you can find out for the ACK, the transmission time, the length upon bandwidth, only you need to do 40 upon the bandwidth, which is 12. If you find out, it is 0.27 milliseconds. Okay, these many milliseconds. Can you calculate these three numbers? Just length upon bandwidth you need to do. Transmission time for all of them. Once you find out the transmission time, I think you can do the same thing, right? I mean, if you want to calculate numerically, then I mean the formula will remain same. So 8 into TT plus TP. So they are finding the RTT and all. Sorry, this is not 8. This is 83. Then everything is same. 83 into whatever we are getting plus for the partial time, partial packet, which is the transmission time plus all of this is basically coming out to be this number. Okay, you can calculate this. So finally, this is coming out to be 2101.8 milliseconds. So this is coming out to be 2101.8 milliseconds. Let me know if this particular formula is fine to everyone. And then you can calculate. See, in this formula, can you not calculate the transmission time for the full packet, which is 1 millisecond? Can you, okay, this is given. You don't need to calculate it. Can you not calculate this? What is this number? This is 40 upon the bandwidth, right? Whatever is the bandwidth, because the length is 40 here for the acknowledgement, right? So you can definitely calculate this. This is given to us, which is 22. So you can calculate all of these numbers. Similarly, you can calculate the transmission time for the partial packet, which is coming out to be 0.573. You can calculate this. This is given. This is also, we have just calculated. This is also given. So ultimately, if you sum all of this, this is coming out to be 2101.8 milliseconds. Is this fine to everyone? Okay. Okay. Now, if I ask you what is the throughput here? If I ask you what is the throughput here? So let's just solve this question. What is the corresponding throughput? The total amount the user transferred is this. So, I mean, in terms of this, you need to find out the throughput in terms of these many bytes of user is transferring over the total time required to transfer it. So the total time we have calculated is coming out to be 2101.8 millisecond. And the data that we are sending is basically, they have also written down the throughput data sent, the actual data, okay, apart from the header, because they have also defined it like that, 122,000 bytes, time taken 2101.8 milliseconds. So the throughput will be, I mean, you can definitely find out the throughput right from here. So it will be just division of both of this. Okay. Yeah. In terms of byte, if you calculate the throughput, this is coming out to be the throughput. Cool. So by the way, the purpose of this question is to make sure that you understand that in stop and wait, if you are having multiple packages to send, then it's not like that the way we have done it before. Okay. So basically you need to stop and wait. You can't transmit all the packets. It's not a pipeline here. Understood? Cool. Now let's see this question, which is, I mean, very straightforward question, but still let's just see this question. So this is question number 13. And what they are saying is this. They're saying that Alice and Bob connected through the network shown like this. There is a router in between them and the bandwidth is also given to you. Now that's a very simple question. They're asking just the maximum possible throughput that you can have. What is the maximum possible throughput from Alice to Bob? That question is from Toronto University. See, if you are having different bandwidth, then what are the bottleneck bandwidths? Bottleneck means that what is the minimum bandwidth? See, I mean, bottleneck means this is the bottle, let's suppose, and this is the neck of the bottle, right? So generally, the speed is determined by that. Okay, with this neck, that okay, if this is very thin, then you can't send the data in a very good speed, right? So here the speed will be determined by this bottleneck. What is this bottleneck? This is 1 Gbps. So the maximum throughput that you can have at most 1 Gbps. You cannot have more than that. See, the maximum throughput is bandwidth. But here in this case, the bandwidth, I mean, if you are having multiple links, then the bandwidth means the bottleneck bandwidth. So what is the bottleneck bandwidth? It is 1 Gbps. So that is why I can say that bottleneck bandwidth is the maximum throughput that you can have. So this is the maximum throughput. You cannot have more than that. See, for example, it is saying in 1 second, you can send 1 GB, right? Can you send in 1 second more than 1 GB? In 1 second, whatever you do, can you send more than 1 GB? Never ever, right? I mean, from LS to Bob, if you want to send, you can't send more than 1 GB because this is the bottleneck here, right? So never ever you can send more than 1 GB. So that's why maximum you can have 1 Gbps, but it depends on the protocol you are using. It depends on many other things, that how much this LIS is actually sending. Maybe it is not sending too often, then may not be 1 Gbps, but a maximum could be 1 Gbps, right? That's I want to say from this question. Now let's solve this question. This is I've taken from some university. So let's just see what they are saying. Suppose we have a network connecting two hosts with RTT of 100 millisecond and bottleneck link rate 30 Mbps. Suppose that one host is trying to send a message to other. That is the communication in one direction. So what they are saying, that two hosts have RTT of 100 millisecond it is given to you, and the bottleneck link rate, which means the bottleneck bandwidth they have given, is 30 Mbps. Okay. So connection is in, let's suppose, in only one direction. Trying to send message to. Okay. Now assume that packets are this 1500 bytes and there is no queuing delay in the routers. What is the maximum throughput between two hosts? What can be the maximum throughput? See, they are saying, they are not telling you any other protocol information or any other limitation. They are saying that you are having this as bottleneck speed. This is the RTT. That is fine. But this is the bottleneck speed, right? So if you take use of this bottleneck speed at maximum, then this will be the maximum throughput, right? So the maximum throughput that you can have is basically 30 Mbps. Okay. So if you see that, okay, this is governed by the bottleneck link. Okay. Now let's just see, in standard one packet stop and wait protocol, what percentage of maximum throughput will be used? Which means what they're asking is efficiency. Okay. So if RTT is this much and you are sending 1500 bytes, so in 100 milliseconds, how much you are sending? 1500 bytes. Now, in 1 second, how much you will be sending? You multiply by 10 both sides. In 1 second, you will be sending 15 into 10 to the power 3 bytes. Is this okay to everyone? Now, what is the throughput? Sorry, yeah, this is the throughput. So if you just tell me in terms of bytes per second, then you will say 15 into 10 to the power 3 bytes per second. So what will be the efficiency? Can you tell me the efficiency now? Efficiency is what you are actually doing, 15 into 10 to the power 3, right? Bytes. So let me convert that to bits, which is 8 bits per second, upon what you could have actually done into 10 to the power 3, 10 to the power 6 bits per second, right? So this is the efficiency. I mean, if you want, you can convert that into the percentage by 10 to the power 2. So that is coming out to be 0.4%. Okay. This is 4. This is 10 to the power 3. So I mean, if you check it, this will be 0.4%. Okay, in terms of percentage. This is the efficiency. So that's what they ask, right? They are saying that what percentage of the maximum throughput that you are actually doing, which is nothing but efficiency. Have you understood this question? Okay, so all of these questions are just to make sure that you are get used to of these terms, that okay, what is maximum throughput that you can take and these things, so that now we are going to solve gate PYQs. Now you will be much comfortable in the terminologies itself, right? By the way, it was a good question. For me as an gate aspirant, if I see, then it was a good question. Have you understood this? Let me know if there is any confusion here. See, the throughput, the maximum throughput is basically just 30 Mbps. And what is the efficiency? It's just that, okay, in this RTT, what you are sending. Very nice question, right? And then you can find the efficiency. I mean, now you have the throughput, then you can find the efficiency. See, they've also done the same thing. They first found out the throughput. This is the throughput. And then they found out the efficiency also. Okay, this is the throughput. Cool. Now let's do this question, which also seems to be a good question, which I have taken from MIT. Okay. So let's do this question. What they're saying, a sender A and the receiver B communicates using stop and wait protocol studied in 6.02. There are n links on the path A to B. So they are saying there are n links on the path each with the data rate r bits per second. So n links in the path, okay, not the hops. So n links, one link, two link, and B. Now each of the link is having some bandwidth of r bits per second. So the bandwidth is given for each link is r bits per second. The size of the data packet is s bits and the size of the acknowledgement. So they have given the length of data is s bits per second. And the length of acknowledgement is also given to you, which is k bits. Sorry, this is not per second. So k bits, right? Yeah. Each link has a physical distance of d meters and speed of the signal propagation over each link is c meters per second. So they have given for each link also, they have given some information. Distance is capital D meters. And the velocity is also given small c meters per second. Okay. Some information they have given. The total processing time experienced by the data packet and the acknowledgement is TP seconds. So the processing time for the data and acknowledgement both are given to you, which is same. Okay. Which is given to you P seconds. Acknowledgement traverse in the same link, the data as per the opposite direction on each link, the propagation time and the data rate, propagation time and data rate are the same in both direction. Okay, there is no queuing delay, everything perfect. Okay, each link has a probability. Okay, each link has a packet loss probability is P. So which means they are saying that the packet may or may not go on this link. I mean, it can be lost, right? So the probability also given to us of packet loss is P. Okay. And packets can lose independently, right? Now they're asking transmission time for a data packet on one link between A to B. Can you tell me the transmission time? What is the transmission time here? From A to B. Okay, total transmission time. Transmission time for data packet on one link. Okay, on one link. So let's just solve this question. I think this is easy one. You should be able to solve that. For any link, what is the transmission time for the data packet? Length. What is the length? S. What is the bandwidth? Everything is fine. S upon R, right? S upon R. Okay. This is the transmission time. I think that's easy one. Now let's just solve the next question. Propagation time for the data packet across n links between A and B. Across n links they're asking. So across one link is D upon C. So across n links, can you tell me? Propagation time across n link is ND upon C, right? So let's just first check these two answers. S upon R and D upon the total distance is this much. Okay. Now let's just see the third question. Now they're saying the round trip time, okay, between A and B. Okay, they have also defined the RTT. I mean, some people basically have some other understandings of the RTT. So that's why some questions define it nicely. So they are saying that RTT is defined as the time elapsed between the start of the time of the transmission for the data packet and the completion of receipt of the ACK sent in the response of the data packet. Okay, that's RTT. So what is the RTT for one packet? Between A and B? Between A and B, they are asking. So I think it will get propagated if there are n links. So it will get propagated n times. And the transmission time you will be taking for, let's suppose this is just one hop in between. Transmission time you will be taking, okay. Yeah, n into the same thing, right? Can you tell me this? So the total transmission time will be length upon bandwidth R. This is the transmission time over this hop, I mean over A. Okay. So if we just consider only one in between, if this is B, then you need to multiply the transmission time 2 times, right? If there are 2 links in between, the transmission time will also get multiplied by 2, and the propagation time will also get multiplied by 2. So the total transmission time over all the hops, it will be n into this, and the total total propagation delay is n d upon c, right? Now this is just for the data packet. Now, isn't it the case that in other direction also the ACK will be traveling? So what is the time? Okay, sorry. There is also propagation processing delay, right? Which is p seconds. So this is only just for the, the transmission and all, but the packet will also incur the propagation, the processing delay. So if there is just one in between, then the processing delay is, I mean, the 2 links, then the processing delay is 1. I mean, you need to multiply by the 1 time only. So I think n minus 1 times the processing delay. Now what else? ACK will also be traveling back. For the ACK will also be having n into propagation delay and the what is the propagation delay and the transmission delay? It will be, transmission delay is this much, propagation delay is same, and then it will also be incurring the processing delay, right? So this should be the answer. Right? So ns upon r, this is matching. nk upon r, this number is matching. 2nd upon c, this is nd upon c, these numbers are matching. Plus tp. Okay, they have not written tp explicitly, but yeah, tp is the processing time, right? Cool. So they have not written the TP, but we know that processing time will be this much. I mean, since they have given it. Is this understood to everyone? Let me know. Okay, you're not getting this ns upon r. This is the transmission time for the packet over this hop, over this hop, over this hop. For one hop, it is s upon r. For n hops, it will be n into s upon r. You will transmit at every time. Similarly, acknowledgement will also get transmitted, right? So that is why for acknowledgement, k upon r, n into k upon r. Not getting? Transmission, obviously not at B. Transmission doesn't include the end station. You will be transmitting at A and I mean at these stations. Transmission time will not be at B. Yes. Yeah, right. So basically, let me just tell you again. This is A, this is B. So you will be transmitting, right? Here. Let's suppose this is B. You will not be transmitting here. So if there are 2 links in between, how much transmission time? How much you will need to multiply? You're transmitting 2 times. If there are 2 links in between, right? You're transmitting 2 times. And how much you're propagating? 2 times, right? 2 times. So basically, if there are n links in between for the data packet only, if there are n links in between, then n into TP of data plus TT of data. Okay. So this, okay. So this transmission time and the propagation time, let me first write the transmission. So the transmission time and propagation time we need to calculate. So the transmission time is n into, and also the processing time, right? I mean, it will also be having, let's suppose T processing of data. And since there are n minus 1 hops in between, so the processing time is n minus 1 into p. Okay. Okay. So this transmission time is basically depend on the length, which is s upon r. Propagation time is distance upon velocity, capital D upon small c. Similarly, for ACK, n into TT plus TP plus n minus 1 into P, right? So here the TT will only be the different, which is capital K upon R. Everything is the same. You need to add both of them to get the final time. Okay, that's how they are getting this is an answer. If you add, you will be getting this is an answer. Okay. Yeah, so that is correct. So now let's just see this part D. So part D is saying that what is the probability that the data sent by A will reach B? That's interesting and easy also, to be honest. So if the packet can get lost, if the packet can get lost with the probability P, if the data packet so what you want, what is the probability that this data will reach safely to B? You don't want to get lost here, don't want to get lost here, don't want to get lost at any of the link. So this is not to get at this link and also at other link, So this is the probability the data packet will reach from A to B, right? Is this fine to everyone? Let's just see this answer. 1 minus P into 1 minus P power N. Now suppose they give you that acknowledgement can also be lost, but with another probability. Suppose they say you that acknowledgement can be lost with Q probability. Now, what is the probability that A sends the data to B successfully and also receive the acknowledgement from B to A successfully? There is just one data packet. What is the probability? Can anyone tell me? A sends to B successfully and B also sends to A acknowledgement successfully. What is the total probability? Probability that A sends data and receive ACK successfully. So what is that? It is also easy one. Can you tell me? Data should be reached and ACK should also be reached. So this is the probability. Okay. Okay. Hope you understood. So I mean, that kind of variation that we just did, this is just a part of, the MIT question only that, some other question. So we will be doing one more question later on. Okay. Not today, where we will be having some variations of this. Okay. Some variation of the similar type. That is also the one MIT question. I hope you understood this question. So now all the questions to just make you more comfortable with the stop and wait. In the sense that now you should not be afraid about the ACK times, processing delays, and so on, right? So this particular question is considering all the time, the processing delay, ACK time, and everything, okay, that you can think of. As you can see, the RTT is including all of them. RTT is basically the time that includes all of this. Okay. Let's solve this question, which is question number 16. Let's just see what this says. They're saying that suppose we are working with basic stop and wait ARQ protocol which below appears the statement of the algorithms. Is this the correct statement of the algorithm? Is this the correct algorithm? That while there are frames to send the frame, start the timer, delete the frame, wait for the ACK to send the next frame. On timeout, go to resend. I mean, resend is some label here. Otherwise, on ACK, continue, which means continue in the sense that send the next frame. There is a little mistake here. Can you identify? Yes. Just after sending, I don't think that after starting the timer, we should be deleting. We should not be deleting immediately, right? We should be deleting only on ACK. So maybe the correct one may look like this. This delete can be here, right? And once you receive the ACK, then you delete the send frame. Otherwise, don't delete. Don't delete immediately because you may need to resend. Okay. So if you're deleting immediately, then on timeout, go to resend means you are basically sending the next frame. You're not sending the previous frame, basically, right? Okay. So you can say that here send send frame. Okay. And on ACK, basically you can say delete old one and then increment frame number or the sequence number, right? Frame sequence number. Okay. So, something like this. So basically you delete the old one, increment the frame sequence number, and then you just send that frame, right? Here, you will not be incrementing the frame number, okay, on the timeout. Anyway, so this is just to make sure that you understood that what was the stop and wait. Cool. Now, this is one question. Do you want to take this question as an homework and then we can discuss it tomorrow? So this question is related to different bandwidth in each direction. Okay, which means from A to B, there is a different bandwidth, and B to A, there is a different bandwidth. And then they're asking the throughput. This is also the very easy question. It's not that it is a tough question. It is just that I want you to try this question. It is, quite a very variation here. This is the first type of question where we are having the different bandwidth from A to B and B to A. And then they're asking for the throughput. Okay, just try to calculate the throughput using both the things, which means using the efficiency into bandwidth and using RTT. Right, directly using RTT. Just try to calculate this throughput. And once you try this, just try your best to do this question. I will immediately upload the notes, and then you can definitely try this particular question, which is the gate question, right? And this question and that question is same. They have not even changed the data, I think, right? Little bit data they might have changed, but this is almost same. This question has been directly taken from this MIT University. And later on, Neelit also copied this question. Okay. Later on, Neelit also copied this question from the gate, but the gate copied from MIT. Okay. There is a chance that MIT might have copied from gate, but I don't think that's the chance. There's a very low chance. Maybe I can see the year. Actually, that is also there in the Berkeley University. So if you check, that is in the fall 2007. That in the Berkeley University, it was in the 2007. And here it is in the 2016. So they have copied it directly. Okay. So anyway, just do one thing. Just try out this question, and then you try out this particular gate question. Okay. So this question, let me just tell you, it might not be very easy, but you try your best. Now you can try your best, okay, to solve this question using this RTT and using this efficiency. It might not be very easy, but I think you can do this. You can find out the throughput. Just see that, okay, how much data you're sending like that. Okay. Cool. Then we can discuss this question tomorrow. This is a very good question. Now, there are a few other questions that we want to discuss. So, but we will be discussing them later on. Okay. Yeah. Cool. So thank you, everyone. That is all for today. Now we will be discussing these questions tomorrow. Right. Now, are you more comfortable with this efficiency and these things? Now, what you can do, you can try out all the gate questions that you have. Okay, you should be able to do almost all the questions. Not almost, you should be able to do all the questions related to stop and wait, efficiency, throughput, and these things, right? These are just easy things. It is just that sometimes the question can be little tricky in the sense that they give you the acknowledgement time and these things. Okay, the last variation that we have here is that different bandwidth in both directions. Okay, you also try out this question by your own, and then you can also try out the rest of the this stop and wait questions which have been asked in GATE. Okay. So thank you, everyone. Take care. Bye bye.